Okay, 2017 paper 2, question 5. In a survey, the IQ score of 1,200 people were recorded. The mean score was 100 and the standard deviation was 15 points. Assuming that the IQ scores are normally distributed. So normally distributed just means this typical normal distribution shape of a graph, where it is symmetrical about down here in the middle, right in the middle, which is the mean. So the data is shown in the diagram. Fill in the missing numbers. So the mean will always be the very center line here. That will always be the mean. You'll find the mode and the median here as well. Okay, so that would be all the averages are right there. So that's your mean, and it tells you the mean score was 100, so mean goes in there. Then they let you know that the standard deviation is 15 points. So to get +1 standard deviation, add 15 and you get 115, add 15 again, 130 for 2 standard deviations, and add 15 again to get 3 standard deviations for 145. And obviously subtract them this way, -15, so between here and here, just to revise, it's going to give you 68% of the population, -15, so from here to here will give you 95% of the population that I've written down there, and -15 again will give you just 55 up to 145, then will give you 99.7% of the population. So part 2 then, a person is chosen at random from those surveyed. Use the empirical rule to find the probability that this person has an IQ score between 70 and 130. So when I'm looking between 70 and 130, I can see it is ±2 standard deviations from the mean. Okay, so between 70 and 130 is ±2 standard deviations. That refers to 95%. Well, if it's 95%, its a probability is 0.95, and that's all you need to do there. Use the empirical rule to find the approximate number of people surveyed with an IQ score of between 85 and 115. Okay, between 85 and 115 is ±1 standard deviation. Okay, ±1 standard deviation. That gives us 68%. So you have to know these numbers off by heart. You have to know 68%, 95%, so 68% between here and here, 95% between 2 standard deviations, and 99.7% between 3 standard deviations, ±3 standard deviations. So now you have to find 68% of 1,200, which is 68 all over 100, multiplied by 1,200, gives you 816. The last part of the question is not a statistics, but a probability question, but we might as well finish off the question here. And this is how I like to do these type of questions. There's other ways of doing it. If you've learned another way, that's grand. A class of 24 pupils is made up of 10 boys and 14 girls. Chemistry is studied by 6 of the boys and 9 of the girls. A pupil is chosen at random from the class. Find the probability that the pupil chosen is a boy, or, really important word there, or is a pupil who does not study chemistry. Okay, so I know there's 10 boys and 6 of them study chemistry. So 6 of them study chemistry. That means 4 of them must not study chemistry. And I know there's 14 girls, and I know 9 of them study chemistry. So the girls, there's 9 of them study chemistry. Therefore, 15 must not study chemistry. So the question was, find the probability the pupil chosen is a boy. Well, all my boys are 6 and 4. Okay, so because it's or plus 4, or is a pupil who does not study chemistry. So this is the other pupil that does not study chemistry. I can't count 4 a second time. So that's very important. You don't count 4 a second time. So it's going to be 6 plus 4 plus 5 gives you 15 out of a total, which is 24, gives you 5 all over 8. And just maybe another way of writing it without having to do it, you could say your boys were 10 all over 24, and you'd have to know in your head and not be repeating the boys that do not study chemistry would be 5 all over 24, and you come up with the same answer.